Hi, this tutorial we're going to look at a different way to sort of um, find vertical and horizontal asymptotes, and we're also going to add on to that the intercepts, which we've done that before with other types of functions. We're just going to look at how we would deal with that with these rational functions. So in order to use this method, the first thing we're going to need to do is memorize a few rules about how the degree of the numerator compares to the degree of the denominator. So in this case, the numerator has a degree of 0 because there are no variables, there's no x's in the numerator. So we have essentially 7x to the 0th power. And then in the bottom, we do have an x to the first power as my highest exponent. So that means the degree of the denominator is 1. So those rules I was referring to, if you have a degree in the numerator that is less than the degree in the denominator, such as what we have here, what you're going to have is you're going to have a horizontal asymptote at y equals 0. Now, if you have it the other way around, where the numerator is larger than the denominator, you're not going to have a horizontal asymptote. Now, the third case we could look at is what if those two degrees are equal? Well, in that case, we actually saw that happen in an earlier example from a different video. We had this function x over x minus 1, and we also had this function 4x squared over 2x squared. Notice the degrees on the top and bottom are equal. So in the first example, the asymptote ended up being at 1, the horizontal asymptote that is, because this fraction of the two coefficients, 1 over 1, is 1. And how I got those coefficients was simply what's the first coefficient? Um, what's the highest degree coefficient, in other words? Down here, we can do the same thing. The highest degree coefficient is 4 over 2. So since our degree was the same, that told me I had a horizontal asymptote at 4 over 2, which meant that I had a horizontal asymptote at y equals 2, because 4 divided by 2 is 2. So in that case, you would have your horizontal asymptote would essentially be the fraction of your highest degree coefficients. So y equals whatever those coefficients are, we'll call them a and b. Those are your highest degree coefficients in the numerator and the denominator. So let's go back to our example at hand. We decided, based on our rules, that since the numerator's degree was lower than the denominator's degree, that we were going to have a horizontal asymptote at y equals 0. Now, to find the vertical asymptote, what we're going to do is we're going to figure out where this denominator is undefined. So, or where the denominator is 0, which would cause the whole function to be undefined. So how to do that, we would set x plus 5 equal to 0, which makes x equal to negative 5. So we know that we're going to have a vertical asymptote there because that is where the function is undefined. Now, we can also use that to state the domain because we know that x has to be not equal to negative 5 and part of the real number system. So that's my domain as well as where I can find my vertical asymptote. Finally, we want to find the x and y-intercepts, and that's just like we've always done. To find the y-intercept, we're going to take k of 0. K of 0 is 7 over 0 plus 5, which is 7/5. So that's my y-intercept. And my x-intercept is going to be where the numerator is actually equal to 0. there is no place where 7 is equal to 0, so I have no x-intercepts for this graph. We're going to look at an example next where we do have some x-intercepts. But before we do that, we want to look at this one, the graph. Now, obviously, you can take a look at this on your graphing calculator as to what the graph would look like, but we're going to try our best to at least sketch what it's going to look like. So we know that we have a horizontal asymptote at y equals 0, which goes right along the x-axis. We know we have a vertical asymptote at x equals -5, so it's going to look something like this. And the rest is going to depend on how the graph behaves going in each direction. So the one last thing we do know also is that we have a y-intercept at 7/5, so somewhere around here. And I can probably deduce from that that my graph's going to go like this, since it has to approach both of those asymptotes without crossing. Now, if we were to look at some numbers on the other side, you might find as you approach negative infinity, your numbers get closer to 0. And as you approach -5, your numbers should get close to negative infinity. They should get larger and larger in the negative direction. Like I said, you can just check that, double check that with your calculator, but this gives us a very nice rough sketch of what that graph is going to look like. All right, so now let's go ahead and take a look at this example using those same methods we just did for the previous one. And we have x plus 1 over x squared minus 4. The degree of the top one is x to the first power for my highest power. And on the bottom, we have x squared as my highest power. So since the top one is less than the bottom one, that means that I'm going to have no horizontal asymptote in this case. So then we're going to go straight forward and try to find the vertical asymptote, which, remember, is where your denominator is equal to 0, because the function can't exist at that point. So when we solve this one for x, we're going to get x squared equals 4. And then remember, when you take the square root, you're going to get x equals plus or minus 2. So that means I have a vertical asymptote at both x equals -2 and x equals +2. And by the way, that I might as well just state my domain here, x such that x cannot equal plus or minus 2, and x is also a member of the real numbers. So the next thing we want to look for are intercepts. And like I said before, finding the y-intercept's pretty simple. We just want to find f of 0, which in this case is 0 plus 1 over 0 squared minus 4, which essentially is going to give me -1/4. So my y-intercept is at the point y, where y equals -1/4. And you can feel free to find the x-intercept as well. And what that's going to be is wherever the numerator is equal to 0. And for this one, it's pretty easy. X plus 1 is equal to 0, so therefore x equals -1. I have an x-intercept at where y equals 0 at x equals -1. Now, the graph of this one's a little trickier, so I just went ahead and graphed it for you. But as you can see, all of our constraints hold true. Well, actually, I see that I made an error here, and I'll have to go back and put in a comment so you don't get fooled here. I said there's no horizontal asymptote, but thinking that it was a different case than the one we did before, but it actually is the same uh, situation where you have the x on top is a lesser degree than the x on bottom. So remember we did before, we do have a horizontal asymptote at y equals 0. So that's my mistake. I apologize. Um, Hopefully that didn't cause you too much confusion. But we do have a horizontal asymptote at y equals 0. And my vertical asymptotes are at x equals -2 and x equals +2. And as you can see, my x-intercept appears to be at -1, just like we predicted. And my y-intercept appears to be at -1/4. So again, in this one, we do have a situation where the numerator is a lesser degree than the denominator. So see if you can remember what that means, and also see if you can factor that denominator out to see what you would get for your vertical asymptotes, and see if you can figure this one out.